Hi guys, so this is a follow-up tutorial to the Arduino and Android Bluetooth relay control. A few people have asked me on ways that you could actually automate this. So what I've actually got here, I'm using the Bluetooth electronics application again, just for visuals and obviously control. So we've got the analog readout of the temperature here, we've got a digital just below it of the readout, we've obviously got an indicator for when the relay is active or inactive, and we've also got the thermostatic slider here which is setting the temperature. I've actually got it set to 22 degrees at the moment. So what's actually happening now is obviously these two are communicating together. Actually no, they're not actually communicating together. It only communicates the once, obviously when you send the value, and they're no longer communicating anymore, so I don't even know why I said that. Once you've set the temperature is stored within the Arduino. It stores that temperature setting, which is obviously 22 degrees, and when it goes above 22 degrees, obviously you hear a click, the relay kicks in, the fan turns on, it blows onto the BMP at the moment, obviously to speed the process up, and maintains that BMP sensor at 22 degrees. Obviously when it goes below 22 degrees, which it doesn't really go below because I've got it set in such a way that it's actually picking up the decimal, so you don't really see any change in temperature on it here. It's pretty much maintaining it at 22 degrees. So what I'm going to do is I'm going to take you to the code. It'll be easy to take you through the code first, it's really simple, and then we'll come back to this and then I'll show you how to actually put these together. Like I say, I mean there's not a lot really to it. Obviously I've cut the wire for the fan's power, and then put them on the open side of the relay, so obviously when it turns on it closes the circuit, obviously powers it up. Taking 5 volts from the board. I have got a second relay, this one here, obviously I'm using the second one as well. Obviously in a room environment it would be, you know, obviously you'd have your heater set to this side and your cooler set to that side. If you had a room that had to be maintained at a perfect temperature, this would be the way to do it. But at the moment I'm not actually using this one. It is clicking on and off, but you know, it's just because I've got it wired up. But we're only using this side at the moment. Obviously there's nothing else connected, it's just these two. So like I say, we'll go through the code, I'll show you how the code works. Like I say, it's really simple stuff. And then obviously I'll show you how to put these together. I've been lazy again with the Bluetooth and the BMP. I've just slid them into the thing. It saves me wires, it saves time, and it's a lot easier for you guys. Obviously if you're using something different, just bear in mind where TX and RX go, and obviously the A4 and A5 for the BMP. If you get them the wrong way around, it's no big deal really. The Bluetooth's powered, I think I'm on the 3.3 volt rail. Obviously if you wanted more range you'd use the 5 volt side, and put a resistor in line with that. Some people use voltage dividers, I don't. I've never ever had a problem, but I don't recommend it because yours might be sensitive, it might be an expensive one or something, and it might just break. So like I said, I don't recommend it, but if you're not bothered, whereas I'm not really, you can do it that way. Like I say, I'm only using the 3.3, it's pretty close. The range is still about, I'd say about 30 meters. On about 5 volts you probably get up to about 50 meters, but we don't really need the range, to be honest. And it's, like I say, it's a really simple way. I mean, if you could use it to control your heating in your house, and so it's a really good lazy way of turning your thermostat up and down. So if it gets a little bit chilly, rather than getting up and having to go in the room where your thermostat is and turn it up and down, things like that, you know what I mean, you could just set it on here to exactly what temperature you want it at, and it'll maintain that temperature of the room. Like I say, I'll show you how to put this together. Well, like I said, we're only using digital 2 to control the relay. Show you how to wire this up, and then the code for this, it's very similar to before. It's very similar to the Arduino and Android Bluetooth relay control tutorial. It's using the same sort of thing. Obviously the slider for this it'll just be a different letter basically what it sends, and obviously but it's sending the values as well as that, so it's slightly different. So I will show you that in the code and talk you through it. I'll show you how to put these together. Like I say, they're really easy, and once obviously you're built up, it's pretty much set up to go. Obviously in a real world situation I wouldn't use the Uno for it. I'd just use something cheap like a Pro Mini or something. You can pick them up really cheap. I mean, I've seen them as cheap as 2 for 99 pence, so you're not going to be that worried about it. Whereas something like this, I don't see the point of using, you know, this board that I can prototype and do other things on just to do this. This is why, like I say, I do projects and things and I just pull them apart, because I don't see the value of leaving it as it is and using it as an actual thing. You know, I always downscale it to a Pro Mini or something cheap that I'm not that worried about if it's sitting there and obviously not being used to its full potential. You could quite easily stack other things to this. If you was, let's say you was at a grow room or something and you wanted to control the temperature of that room, as well as like you say, if you had an extraction system or some system that takes or adds moisture to the environment to make it more humidity or less humid, you'd use a humidity sensor. You could, I'm not sure whether they use the A5 and A4. If they do, as long as these are addressed, they've all got their own addresses. The BMP's got an address. As long as you're using them addresses, you can daisy chain them, and they'll still work as long as the addresses are there. You see. If you don't, it'll just use the default, I'd imagine anyways. So you could quite easily add that. So if you had an extraction system or some system of taking the moisture out of the air and you wanted to maintain a perfect humidity, you could quite easily just add that to this. You wouldn't have to change it, or you wouldn't have to rework it all. You'd literally you could add it to this and just add a few lines to code. It's not that hard. It's really simple stuff. It doesn't have to be a BMP sensor. You could quite easily be using a light sensor, some sort of a photonic resistor that obviously you'd be using obviously your analog lines then, so you'd be using AO, and obviously you'd be using the voltage difference. You'd set that up as how you wanted it really to maintain a certain light level in a room. Let's say if you wanted to turn a light on or turn a light off, if you could add a time system to it. With the time chips, I did have one somewhere, but I'm not sure what I did with it. I don't even know what I'm talking about that, so ignore that. So anyway, what we'll do is we'll go to the thing here. I'll talk you through the code. I'll talk you through how to put this together, and I'll also show you how to do it this side as well. And hopefully, I will put the code up. I'll upload the code to a site. I mean, personally, there's not much code there. You're better off following the tutorial. Like I said, I'm going to show you where it is. Just pause the video, you know, and just copy the code down as I'm doing it. If you're doing it yourself, you're going to learn a lot quicker that way. And obviously, then you can play around with the values and things like that. You know what I mean, and get it to how you want it. You might want a buffer in between. So rather than have it dead on 22 degrees, you might want a buffer. So a range like between 20 degrees and 25, you could quite easily do that. So you could have it so it turns on when it hits 25 degrees once you've set it, but then it'll fall as below as 20 degrees, let's say, and then before it turns back on again. It's like I say, it's all code sided, so it's quite easily to do. The app on this, I've had to add this bar here just to indicate where 25, 0 and all that, just to give me a rough idea on this bar, because there's no indication to the level. There is a delay once you move it, so if I change that down to, let's say, I don't even know what it's going to go to, so it's at 12 degrees now. It took about a second. That's because of the there's a slight delay for the Bluetooth, so it doesn't lose any data basically on transfer. I might change that in the code actually to speed that up, because I think it's a bit annoying, to be honest. Obviously that's bringing the temperature down now. It's gone down to 21.6 and it'll continue to fall. I don't think it'll get down to 12 degrees because, like I said, I'm just using a fan to cool it, so the ambient air temperature that's being blown through is not gonna get you down to that temperature. But this could quite easily be, instead of being a fan, you could have an AC unit that could be turned on your AC right now, and obviously that's going to do a better job at bringing these temperatures, into reality. And obviously, so basically, if you've got a room it's always cold and you wanted to maintain a warmer temperature, then you could quite easily, with the code hour I've got it now, if you've got a 2-channel board like this, you'd literally just connect your heater to this relay here. And obviously, when that goes above the temperature, you see. So if I go this side of it now, you'll see this one turn off and this one turn on. So that would now turn your heater on. You know what I mean? So obviously then that would warm up the room up to 33 degrees, cook your ass off, and then Bob's your uncle. So basically what I'm going to do is I'll set that back down to around about 22 if I can get there. This phone's really old, so it's not the best at the digitizer on it. So I've got it set now to 22. Obviously we're at 21.6, so once that raises back up to 22 degrees, it should do. Put my finger on it, won't melt quicker. Right, we're back at 22 degrees. As soon as it goes over, it'll obviously click on. Bearing in mind, like I say, the board itself, it's where it's getting the temperature from. The board at the moment is quite cold. It's been cooled down. Right, so we're back on at 22. We're at 22.2 here, 22.1, and then I'll go to 22, and obviously it'll click off. So anyway, enough nagging from me. What I'm going to do is now, like I say, I'll take you through the code. We'll come back to this, and then we'll do the rest. Okay, so here's the code. I've added these in just, you know, the pins and that for the BMP and the Bluetooth, so you know where the wires go, just in case you're unsure of anything. It's something to check against, and obviously a little bit of advice or ideas or whatever on this bit here. Like I say, you don't have to listen to all that. It's at your discretion. This include, I'm going to have to upload that. You are going to need this library here, for the BMP, and y.h. Everybody's got that. It's default with the IDE. So the first one is thermo, which is basically our slider for the thermostat. You know, obviously we're using it as a thermostat, so I call it thermo. The value we have left it as 0. That could be your startup temperature. So if it was, let's say you're using the heater, so you wanted it for controlling the temperature, your room's pretty cold, you want to keep it at, let's say, 18 degrees, you could quite easily set that to 18 degrees in the code before you upload it. At least that way then, every time you start it up, it's always going to be set to 18 degrees. But if you want to change it, obviously all you do is you go on your phone, you slide the slider, and that value will change to that value. So that will change, so it doesn't have to be 18, you can leave that as 0, it'll change in accordance with the slider. We've got relay 1, which I've set to digital pin 2, and we've got relay 2, which I've set to digital pin 4. You don't have to call that relay, you can call it whatever you like. I've kept it as, obviously, so you know what it is. I've just kept it simple. D, this value is basically, it's what I'm using that letter in the delay, so I've just put delay set in there, and I've obviously all that D is doing is representing this number. Obviously we've got character Bluetooth data, which is a way of talking to and from the Bluetooth, and you know, that has to be converted into characters basically. This is a function that's needed something to do with the library. I'm not sure what it does, but you do need that on there. We've also got our setup, so we need to set up, so we want the Bluetooth begin. Obviously we're using the serial to communicate. That's what the Bluetooth's using, that's why it's on the TX and RX pins, which is basically the serial. So there's the data, and obviously I've got the message there connecting, which is going to stay there for 1.5 seconds, so we'll just check that. So connecting, yeah, it's a wrap. That's pretty much bang on 1.5 seconds. So now we've got pin mode. Obviously this is for pin 13. We're going to use the pin 13 as the indicator light. Basically we're not actually using the pin, we're just going to use the indicator light that's default on the Uno board. You don't have to use this. If you don't want it, you just don't write it in basically, but I'm setting that as an output, otherwise it won't actually turn the light on and off. Also we've got pin mode for the relay and the relay 2. They also have to be set as outputs. Your digital pins by default I believe are like a digital read. I think that's the state by default, or they might be in a dormant state, I'm not too sure, but you do have to set them as outputs so they won't work. They won't actually trigger the relays even though your code's working. Obviously if pressured up against, that's basically checking. It's basically the Arduino is going to talk to the BMP to see whether it's there. If it's there, obviously I'm going to send that message there saying connected. So it's established a connection, so we're just going to get the message connected. You don't have to put connected. You could put anything you want, anything as stupid as you want. It makes no difference. It's just a way of just basically debugging things. Should you have any problems at a later state, let's say you've had it running a few years and problems, you know, and you can't remember quite within the code, and it was that long ago when you did it, you see you can't remember what's doing what. It's just a good way of checking, fault finding, that sort of thing. So obviously if we first start up and it doesn't get that, it doesn't talk back, obviously there's some problem. Either it's not powered up properly, one of the wires are off the BMP, or even the BMP is faulty itself. Obviously we're going to have it then send that message. So what I'm going to do now is I'm just going to start open the serial monitor so it reads that, 'cause
every time you open the serial monitor, you see it'll actually it's basically like rebooting the board. It's like pressing the reset button. So that's going to reset and obviously start it up. So obviously we've got connecting, and obviously we've connected as we've just shown there in the code, and now it's reading the information that's coming through. And that's it. That's basically the information that's been sent to and from the application itself. The app uses obviously the characters, the T. So we've got T23.6, which is actually, it's the actual temperature it's reading now. So if I was to put my finger on the temperature sensor, that value will start going up, as you can see. That's basically all that is. And obviously it's green, set it green at the moment because that's to do with the code. It's actually on, it's in an on state because it's set to 22 degrees, I think. So as long as that's above 22 degrees, that's obviously going to be green, and then it will change to the red one will be 255. I'll talk more about that in a bit. So what I'm going to do is close that. I'll disconnect the BMP and I'll start it up, just to show you that obviously it's connecting and there's an error. So obviously it'll stay that now. If I do manage to find the problem on it, that's not going to change. So don't use that as a debug, in the sense that, you know, should you find the problem, that it's going to start reading. It's not going to work like that. It's actually going to stay. It's not going to let you do anything until, you know, you've gone through the problem and you've actually reset it. So what I'm going to do is close and then reopen it. Now I've found the problem, and reopen it, and that's going to reset the board, and obviously everything's fine. Now we're working again. Should you have a problem though, whilst it's actually up and running, it's connected, you know, you've got things working and you accidentally pull a wire out or anything. So I'm going to just simulate that now and just unplug it. Obviously we get a thing in, get a message saying loose wire. So you know that something's definitely, you know, gone wrong. It's not always going to be a wire. In this instance, that's basically what's happened. But if it's not the wire, if you're messing with the wires and it doesn't restart talking to it like it has done now, look, see, it's established the connection again and it's starting to read the data as soon as I plug it back in. If that doesn't happen and it's still saying that, there's a good chance that maybe your BMP's damaged or not working. Example is, you might have accidentally plugged it up to 240 volts and there's flames coming out of it, you know what I mean? So it's going to continue saying that there's a loose wire even though it's on flames and you can clearly see that. But obviously in that instance you're going to know that it's pretty much goosed, the fact that there's flames coming out of it. So we don't need to worry about that. But as a debugger though, it's a good indicator to you've got a problem. So I'll come to this. This is serial available, so this is what's going to, obviously we're using the serial to communicate between the Bluetooth. Well, I say the Bluetooth, it's the way the Bluetooth sends the data. It basically uses serial. So obviously we're using the TX and RX on the Arduino to the Bluetooth. So it's basically sending a serial stream to the phone app. So that's basically what this is. So if there's any information being sent or data or anything, obviously this is what's listening out. So if it's true, basically, obviously send data, it's going to read the serial there, and then obviously it's going to get the values, thermo and things like that. We're going to be using that later in the code. You will need all of this because it's this line here that the phone app uses to send the info back and forth. Also we've got a chart and status. This double T is to do with the default code. All I could do with the BMP, you see, I wasn't sure how to communicate with those, so this is just what was in their default sketch that they had. You do need that in, but basically we're using that there T, which we've been using the temperature side of it. Obviously it does pressure and other things, and you can obviously use the difference between these and the algorithm and that, and obviously establish an altitude and things. That's what they're intended for. But we're not using this side. I've left that in case somebody wants to use pressure or whatever. I mean, you can. I mean, I've used them BMPs for actually measuring volumes of water by using the pressure. So you know, you can use things really for what they're not intended for, but as long as you know the math and you can work things out, you know, you can kind of use things for totally different, you know, purposes than what there was intended. So I've left that in anyway. You don't need it, but I'd just put it in just on a sense that everything's going to work properly. So obviously thermo is a slider. So if the slider value, which is what we're setting, is less than T, the T being the temperature of the BMP, so that's going to be room temperature or a temperature that's picking up at the time. Obviously mine's picking up 22 degrees, and we've set the thermo to 22 degrees, so it's pretty much bang on. But if it falls below, then obviously our slider, then we want it to turn something on. So that's what this part is here. So we've got digital right 13, and we've set that high. So we've got an indication on the UNO board that the that whatever we've got connected or turning on is actually switched on, because we've got the light coming on now on the board as a one indicator. We've also got serial.print, and this is basically the indicator. The round light type thing on the actual application. They call them indicators, and that's what I is. I is their default call to it, the capital I. So that's basically an indicator. R is obviously the colour red, and G is green, and B is blue. And obviously, if we set the value to 0 on the green, on the red, sorry, obviously we're not going to get any colour red. We're going to get colour green, because I've set that to 255. So that's like full brightness basically. And obviously the blue we're not using, so that's our indicator it's on as well. So we've got an LED on the board that's going to turn on, so we know that something's switched on. We've also got a green indication on the phone app telling us that something's turned on, and then we've also got the relay, which obviously we've set that to 0 or low because that's what the relay uses to turn on and off. When the relay's low, that's when it's going to turn on. So that's it, although that in a normal instance that would be off, because obviously we're using the relay, which is low sided for turning on. That's actually on, so that's turning the relay on, and we're turning relay 2 off, which is setting it high. If obviously if the thermo is higher than the T, that's going to go to this side of it, which is obviously out. So if that's not true, basically it's going to do this, which is obviously turn pin 13 or the LED on the board. It's going to turn it off. It's going to send that message to the phone application, which is just going to set the indicator red, the red part of it. Basically, we're setting that high, and obviously we're setting the green and the blue. We're setting them to 0 because we don't want that colour there. We just want the colour red. So we've set that full to indicate that the relay is turned off, or the thermostat's at its temperatures, let's say. So that will turn off, and obviously we're setting that relay one on. I say on, I mean high. We're setting that high, which is obviously going to turn that relay off. And then obviously it will turn relay 2 on if we had a heater attached. In that situation, it doesn't have to be those two things. It could be something totally different. Obviously, status is just the pressure, so it's going to be pressure. Start temperature, so it's going to read the temperature basically. It's basically for the BMP, the library, and obviously if the status of it, and then the delay status. I'm not sure what that bit's all about. Like I say, it's to do with the library, so it's not really my code in that sense. And obviously then we've got the get the temperature, which is our T value, and obviously then we're going to print that value because that's what the phone app uses. Obviously to set those things for your visuals. I kept it on T on the thingy. That's to set the temperature on there. So that'll be the digital and the analog. The analog read out the temperature on your phone app, and the digital, obviously it tells you the value. Basically, that's what T is. It was set on that app itself anyway by default. So I just figured I'd just leave it the same in the code. It just makes things easier. And obviously there's our loose wire message and error retrieving temperature. I've not had that problem come up, so I'm not sure what would cause that one. This one I did anyways. That's basically a pause, so I'll just leave that as pause. So obviously that's that value at the top, D, so we know that value there is 250. The only reason I do that, like I say, it makes your life easier. Makes your life easier trying to find it, because if you normally when I use these values, you see, and I want to keep everything running, as quick as possible. Obviously, so I want the smallest delays, so I get better response. I tend to keep the values as close to the same as possible, and rather than having to keep writing the values out on different ones and things like that, I can just do that and just edit it at the top of the code rather than going for each one. Do you know what I mean? Because it'd be annoying having to change all them different values, especially if you've got quite a few of them. So I've just give it a name, which is basically a letter D, which represents our value or a temperature setting. Temperature setting. I mean a delay. So that's just our delay there. Yeah. So what I'll do now is I'll pull all the wires off of this and I'll show you how to build the and wire it all up together.
Okay, so here we are all pulled apart. So what we'll do first is we'll connect up the relay. So obviously your ground, that's to go to one of your ground pins, and the Arduino. Be careful where you connect these, because I like to say some boards it might pull the voltage through the actual chip itself, the 80 mega. I'm not certain on that, so don't take my word for it. Just take it as a precaution. This, like I say, this board's unique in a way where it's actually got a set rail here, and it'll take the power directly from the actual voltage regulator itself, which is rated to 1 amp. I know that because I've looked up the data sheet, and also I do supply these, and I've popped a few as well. But yeah, they deliver up to 1 amp anyway before they start getting warm and toasty. So obviously we want the 5 volts as well. So we've got 5 volts here, which is going to go to the VCC on the board for the relay. This time I'm only going to connect the one. I'm using actual digital pin. I mean, I've shown you in the code, but I'm using the digital pin 2 and 4. There's no point using the ones that deliver PWM, because that could be used for something else. So I'm just trying to keep it as simple as possible. So I connect up the first channel, which is this one here. I'm going to connect that one to 2. Like I said, I'll connect the other one up as well. I mean, it's not really going to be using it, but I'll do it anyways, just in case. And also that one goes to number 4. Obviously with the BMP, we'll connect that up next. If it's this way on the board, those two sit where you need them. So basically your SCL goes to A5 and the SDA goes to the A4. I do it this way, like I say, it's just easier way for me to do it. Less wires and things. So we'll connect the VCC on the ground. This one, this is the VCC on this one, so this is going to go to the 3 volts we're going to be using, 3.3 volts. And obviously the ground, we'll just take the ground rail from here, and then we'll just connect this up, slide it in. So it's facing this way. So as long as that's facing towards you where the metal chip is. Okay, so we'll do the Bluetooth. So we want VCC, and we want our ground. We'll connect the ground first. This is the ground one, ground wire. Connect the ground wire, and obviously we're only using 3.3, so we'll connect the VCC to 3.3. And I'll have to do a bit of magic. I just might get this around this side. I did a boo-boo there. Got into the wrong one. But I told you right, that's all that matters. Okay, so I'll spin this around so that the chips and that's facing me, and that'll be the right way around for the TX and RX. But if you don't know, the RX goes to the TXD on this, and the TX goes to the RXD. So they're basically reverse sorts, just so they can communicate with each other. And we'll connect the power. Now we've connected up. And I'll just slide this back through there just to hold it up and put it back, and as you can see we're running. Like I said, I don't know how it does it, but the temperature still stayed, unless it's set in the cave for 22 degrees or it remembers last, I'm not sure, but it seems to be set to 22 straight off the bat. If it's not, just give it a tap on your application, just change it just so it updates. So actually it's not connected, so what I'm going to do is I'm going to go back and just make sure we connect. So connect to the Bluetooth. If your Bluetooth's flashing, some have lights, some have an indicator light on, some don't, but if it's flashing, obviously it's not connected, so we'll connect that. And the light's solid, so we're connected, we can done, and then we'll run the application. Right, so now we set at 22 degrees. I was saying before, I did actually say that these aren't actually communicating, but when they actually are, obviously it's sending the data from the BMP to this, so you can get the temperature readout. So there is a communication there. But what I meant by there wasn't actually communicating, I was more or less talking about the BMP for this slider value here. This is only ever sent the once when you slide it. I've actually done it so when you slide it, it doesn't actually change until you release, and that's when it sets the temperature. So it's gone to 29 now. Obviously that's too high for it to actually turn on, so we'll bring it back down to, it's 21 degrees, so we'll let it play for a bit. That should bring it down. I think it might get down to 21 degrees with just using the fan, but obviously if it had been an AC unit and obviously in a room environment, then it'd pretty much do the trick. But that's it, it's really, really simple. If you have any problems or anything, just let me know, and I'll try and help you out best I can. I think I've pretty much covered everything, to be honest. Like I say, I'll put the code up there, just in case anybody wants to download the code because they can't bother to code it themselves. I mean, like I say, just pause the videos. You better, if you're doing it yourself, you're going to learn a lot more. And not only that, you're going to learn how the code's actually working. Like I say, I've explained as best I can how the code works, and what's doing what. You can also, I don't know whether I mentioned it on the thingy, but you can actually also, you've got to bear in mind this is just using the serial, so it's all it's using as a serial. So if you was connected to the computer, so if you was using some sort of a connection as we've got here to your Arduino, you could literally use your serial monitor and put in the values yourself. Obviously it has to send the actual correct lines, so if you were wanted to set the temperature, find it a second in the code. So it's just using Thermostat T basically. T is the value.